Question 4. Right, sketch the graph y equals 4x cubed plus 4x squared minus 5x minus 3. The first thing to do here is to find the factors, one of the factors. And the best way to find the factors, one way to do that is to add all the coefficients. And if they equal to 0, then x equals to 1 is a factor. What that meant is if I put 1 here as x, that'll be 4 times 1 plus 4 times 1 minus 5 times 1 minus 3, and that equal to 0. That means x equals to 1 is a root. And therefore, we can turn the root into factor. So what I'm doing now is I take x equals 1. So if I put 1 here and there, and that came out to be 0. When x equals to 1, y is 0. So therefore, subtract 1 from both sides. I get x minus 1 equal to 0. Therefore, x minus 1 is a factor. X equals to 1 is a root. And you can see it here. So one of the roots is x equals to 1. Now I'm going to use factor theorem to find the other roots. So now for factor theorem, if you get a function fx, so this one is, which is y, and you divide it by the factor you know, so there's a factor we know, and that factor is called divisor, and then you're going to get quotient. So g of x is a quotient. So what I'm doing now, just say, okay, fx divided by the x minus 1 equals to g of x, and I multiply both sides by x minus 1, so fx equals x minus 1 times g of x. Because we're dealing with cubic, this is x to the power 1, so my g of x should be x to the power 2, so which is going to be quadratic. So I've written here that g of x is quotient. Okay, so fx is that, and I'm dividing it by x minus 1, so that's x minus 1, and I want to find the result here, which is g of x. So what can I multiply x by to get 4x cubed? It's got to be 4x squared, right? So I'll do 4x squared. So 4x squared times x will be 4x cubed, and 4x squared times minus 1 will be 4x squared minus 4x squared. So I'll multiply 4x squared by x, I get 4x cubed. Now I'll multiply 4x squared by minus 1, I get minus 4x squared. Now I drew a line. So now in order to get rid of the x cubes, I need to take away. So 4x cubed minus 4x cubed will be 0. So now, and then say 4x cubed minus 4x squared, that's 0, plus 4x squared minus minus is plus 4x cubed, that would be 4x squared, that would be 8x squared. Then I bring down the minus 5x because that's what's next. What can I multiply x by to get 8x squared? That would be 8x. So now 8x times x would be 8x squared. 8x times minus 1 will be minus 8x. So now I've done 8x times x, that will be 8x squared. 8x times minus 1 will be minus 8x. Now I need to get rid of the x squared, so I have to take away again. And if I take away 8x squared minus 8x squared will be 0, minus 5x minus 8x will be plus 3x. Now I need to bring down the minus 3 here, down here. So that would be minus 3. Now what I need to do next is, what can I multiply x by to get 3x? So that would be plus 3. Then I'll do 3 times x will be 3 x. 3 times minus 1 will be minus 3. So I've done 3 times x, that's 3x. 3 times minus 1 is minus 3. Drew a line. Now I need to take away again. So if I'm taking away, 3x minus 3x should be 0. Minus 3 minus minus, that will be plus 3 should be 0. Therefore, it's 0 because x minus 1 is a factor of fx. Now I got my quadratic, which is g of x. That's g of x. So now I need to solve this to get the two factors because x squared is the highest exponent. So it will have two factors. I need to try and get those two factors. So a is 4, b is 8, c is 3. So I'm looking for AC in order to factorize this. I'm looking for AC. AC is 4 times 3, that's 12. So I'm looking for two numbers I can multiply to get 8 when I add them. And when I multiply them, I get 12. So I'm thinking 6 and 2. And I'm going to add them together to get the 8. So 6x plus 2x will give me 8x. So I'm going to replace the 6x plus 2x into here to get to my 8x. So I get 4x squared. I'm going to write the 2 first plus 2x plus 6x plus 3. Of course, it's equal to 0 because I'm solving it. Now, what I'm going to do now is there's a common factor here, and that's 2x. There's another common factor here, and that's 3. So I've taken a common factor of 2x out. I get 2x plus 1. So I've taken the second common factor here, which is 3. So that'll be 2x plus 1. You can see there's a common factor between these two. That's 2x plus 1. And I'm left with 2x plus 3. So I need to set this to 0 and set that to 0 to get the roots. These are the factors. So these are the factors that goes with that. So this is one factor, the second factor, and the third factor. So you can see from the factor theorem, the fx equals x minus 1 is one factor, because that's why we use it to divide it, times gx, the quotient. Now I found the factors of gx. So now you can see fx equals x minus 1, 2x plus 3, and 2x plus 1, all equal to 0. So now I'm going to set this to 0. We already set that to 0 because that's how we got it when x equals 1. So I'm going to set this to 0 and find the roots. So I've set that to 0 again, even though we already knew that. I set that to 0 and then take 1 to the other side, x equals 1. Now we're going to do this second one here. So I said 2x plus 3 equal to 0, 2x equals minus 3, x equals minus 3 over 2, which is minus 1.5. So this is the second root. Setting the third factor to 0, I take away 1 from both sides, I get 2x equals minus 1, divide both sides by 2, I get x equals minus a half, which is minus 0.5. Those are my roots. Now I can plot this root now. Use this to draw the cubic graph. So now we know the roots are x equals 1, x equals minus 0.5, and x equals minus 1.5. When x equals, so we know it's cubic and its exponent is odd, so it will start from the third quadrant, which is odd. So therefore, the graph will be coming that way. It's got to cross at x equals minus 1.5, so that's minus 1.5 there. And then we turn somehow. We haven't found the turning point yet. We don't need to, but we could find the turning point by using differentiation. We differentiate that. We get a quadratic, and we set it to 0, and then we solve that quadratic. and we can get these x values here. And then we can find the y value by plugging those x value into this y. And then we can find the y value. And then we get, obviously, because it's quadratic, we get two x values. So we get a maximum and minimum point. So we have to differentiate that. Or we could do trial and error. So we know it's going to turn, and then it turns, and it's going to come back at minus 0.5. Of course, it has to turn to come back to minus 0.5. And then the intercept on the y-axis is going to be minus 3 because it's telling us right there. And then it would have to turn again somewhere in order to get back to 1 and then go all the way to infinity. And so that's how we sketch the curve.